Just making a video for you guys about swapping over this 4070 motor from the 880 to 1060 kV, and unfortunately at the end of the video I can't use it because our lake is full of debris at the moment. We had a massive storm a couple of days ago and we took it to the lake and we couldn't actually use the boat, just full of sticks and stuff. So that video will come next week.
Okay, for those that don't know how to work out your kV and your voltage when you're choosing a motor, it's kV times by total voltage. So the motor they were running in there was 950, the standard motor for these, and so we got 8S. Each cell was 4.2 volts when it's fully charged. Now you can't use that number because under load it's going to be more like 3.9 to 4. So to be safe, go the higher end of the 3.9 to 4. So go 8 times 4 is 32. So we got 32 volts, 4 volts per cell. You times that by that. You want to be aiming for around about 30,000 revs for, you know, like sport boating. If you want to, you know, if you want high speed runs, I suppose, like just short runs where things are going, you don't care if things are going to get hot, you know, you might be looking for 35 to 40, but you know, that's kind of your preference. For things that are going to last, if you can keep it around the 30,000 or low 30,000s, that's ideal. 950 kV times 32 volts. This is the factory. They're going for 30,400, which is absolutely ideal. I just ran the 880 in there. 880 times 32 volts, that's 28,160 RPMs, and now we've got a 1060 in there. It's going to be like 32, 33,000, something like that. If it was 1,000, it would be 32,000. So just a little bit over. 32 times 32, 33.9. Wow. Okay, so that should be the total RPM I've got. It's actually, when you look at data, it's probably going to be more like, especially after it's just after the highest voltage is knocked off, it's going to be more like 3.9 really, but I do use the number 4 just to be safe. But 1060 times 8 times 3.9, it comes to 33.0. Yeah, so 33,000. Okay, so that's okay, but I wouldn't want to go higher than that. So what I'm going to do is lower the voltage, lower the prop size for sure. So I was running a 55 mil on there on the 880. This one, I'm hoping it can maybe handle a 50. It'd be good if it handled a 52, but I'll start smaller. I'll start with a 48, and that's going to be, I think that's going to be close enough, and hopefully I can step it up. So it's going to be all about my temps and whether that prop can turn with this motor on that voltage can turn a 48 mil prop. If things get hot and it's going slower, obviously I'll have to try a lower prop. There's my 1060 kV motor soldered up, still the same size of 4070. On the 880 kV I was using, that was, you know, I just found lying around, it had 5.5 mil terminals on there. The Proboat speed controller has 6.5 mil terminals, so I'd made up some adapters. On this one, I'm just going to go from, I'm going to use 8 mil on the motor down to the 6.5. That's going to be a little bit better. Also, the cooler that was running, that was on here was, I don't know what size it was probably maybe a 65 mil cooler or something. I'm going to run the biggest one I can fit on this motor, which is a 90 mil cooler, just to give it the most cooling it would possibly have. And yeah, that's going to fit on there nicely. It's a 4070 motor with a 40 by 90 mil cooler that we get made up especially for these. Don't think you can buy a cooler as long as that anywhere else. These coolers come with 2 different size O-rings. The fatter ones were or are for the older TP motors that they used to be 39.6 millimeter. So if you put a 40 millimeter cooler on them, it would work, but they were just a little bit too loose. So I got these made up with a tiny bit more, you know, bigger, fatter groove, and with a thicker O-ring. Now they're 40mm again, what they should be. It makes it much easier. So there's kind of no point us selling those O-rings with these coolers anymore. Kind of better if you rip the sticker off. Not I've ever had a problem with one leaking without ripping it off, but you can kind of see why you would. Just twist as you put it on, just so the O-ring doesn't look kind of like fold in itself, like, you know, past the out of the groove. And there you go. It's good that I've still got the marking of the KV exposed, because I'm likely to forget what I've had in there. And I'll just bolt that in now.
Now, just looking at this longer cooler, this cooler was perfect because this raised bit here was sitting on the bottom of the motor mount, and it just made it absolutely perfectly lined up. But now I've got this longer cooler in, it's missing that raised bit, like that's back there, and so it's on the skinnier bit. So I'm gonna have to see if the if the motor still lines up, if the shaft still lines up with the flex shaft. If it doesn't, it's either I'll put a smaller cooler on there, or I might just put a little spacer in there. I'll just see how close it is first of all. A spacer could be something as simple as, you know, a sticker folded over or something like that, bit of paper. Okay, so that's the motor sitting in there, and as you can see, it's absolutely still perfect. So you got a little bit to play with straightness, but you can see my cable there sliding in real easy and straight, so I got no issues there. So as long as you've got a cooler resting on the back of that mount there with the 4070 motor, it just makes it right. If you didn't have a long enough cooler, or you had a shorter cooler that was too far forward, it's not going to line up properly. But that is perfect. Okay, so this cooler's got nipples you can turn around. When you're doing your cooling, the ideal way is to put the water in the lowest side and make it fill up and then come out the highest. So I'm not going to put it straight to there, I'm going to put it onto this one here. They are held on with some Loctite. Whatever you do, if you need to turn it 180 degrees, don't keep turning it, you're just going to probably strip it out. So just come back. Okay, and just shorten it to where you need it. What have I got here? Got that holding that there, so I'll probably go here. Holding the GoPro at the same time, not that easy. I'll just trim that to about there, I suppose. I think the inside diameter of this hose is just a touch smaller than the stuff we sell. This seems kind of tight, like on there, but it's working. Okay, so that's that one, and my outlet's just going to be the same, just out to the side. All right, is it going to be worth the upgrade of the expense of, you know, putting a 4070 motor in there? I don't know, possibly not. We'll find out. If you were just looking to do speed runs, I guess it's going to, yeah, I'm going to be able to find a way to make it faster, but will it be fast enough to make it worth the expense of that? I don't know, may not be. I'm not actually looking for the highest speed I can get. If I can't have the boat run for, you know, 3 or 4 minutes at flat out, I don't think it's worth doing. You know, that's just me. You know, I don't want to have a boat that flattens its batteries in 2 or 3 passes and makes everything run hot. It's got to be reliable and stay cool, and I may not be able to achieve that like with a 4070 motor.
personally for me, if I wasn't doing this for a video for YouTube, I would simply just get rid of that speed controller, put a 12S capable speed control in, like a ZTW 300 amp, find a motor that suits that the best, which is something similar to what I had in there before, the 880, or even lower than that, maybe 600 or 700 kV, probably even better. And then I could guarantee to have a boat that's fast and reliable as well. Just mucking around on 8S, you're kind of limited to what you can do. It's a big boat, and yeah, it's just, I'm not sure I'm going to be able to get where I need to be honest, but we'll take it out today and see what happens.